The air itself seems to buzz with menace. It's not the sound of jets or helicopters, but something smaller, angrier. There's this high-pitched whine that rises and falls, echoing across the scarred landscape. On the ground, a column of armored vehicles kicks up dust, their steel plates designed to withstand bullets and shrapnel. But, honestly, they weren't designed for this. From the horizon, they appear, tiny black specks, moving with impossible speed and agility. They aren't flying in a straight line, instead they're jinking, diving, and weaving like a swarm of angry hornets. This is the new face of warfare, and it arrives with a digital scream. For the soldiers inside those steel beasts, the world kind of shrinks to the narrow viewports and periscopes. The sound is the first sign of trouble, a faint, almost insect-like hum that grows louder, more insistent. It's a sound that promises danger from an unseen enemy. They scan the skies, but the drones are just too small, too fast. One moment there's nothing, and the next, a dark shape is hurtling towards them. There's no time to react, no time to aim, no time to even breathe. The pilot, hundreds of miles away or maybe just over the next hill, sees the tank fill their screen. A perfect target locked in their sights. A final, decisive flick of the controls sends the drone on its terminal dive. The first impact is a flash of brilliant light, followed by a deafening crack. An RPG warhead, strapped crudely to a carbon fiber frame, detonates against the turret of the lead vehicle. Smoke and fire billow into the sky. Before the crew can even process what happened, another drone strikes, and then another. They target weak points, the engine block, the tracks, the seams in the armor. These aren't multi-million-dollar missiles fired from a distant warship. They are cheap, disposable, and utterly relentless. The battlefield, once a domain of massive machines and strategic formations, has been invaded by something new. This is the reality of the FPV drone, a weapon born from a hobbyist's passion, now repurposed into a terrifyingly effective tool of destruction. It represents a fundamental shift in combat, where speed, agility, and sheer numbers can overwhelm even the most heavily fortified defenses. The cost-benefit analysis of war has, honestly, been turned on its head. A $1,000 drone, piloted by someone with a video game controller, can now threaten a multi-million-dollar piece of military hardware. The swarm has arrived, and it is hungry. It's a game-changer, rewriting the rules of engagement with every explosive impact. So, what are we actually talking about here? FPV stands for first-person view. At its core, an FPV drone is a small, high-speed quadcopter, the kind you might see in professional drone racing leagues. These things are built for one purpose: performance. They're lightweight, incredibly agile, and can accelerate to blistering speeds in seconds. Imagine taking the chassis of a Formula One car and strapping it to a go-kart engine. That's the kind of power-to-weight ratio we're dealing with. They are a world away from those slow, stable camera drones people use for cinematic vacation videos. These are the sports cars of the drone world. The magic of FPV is right there in the name. The pilot wears a set of goggles that receives a live video feed directly from a camera mounted on the front of the drone. When you put on the goggles, you are, for all intents and purposes, in the cockpit. You see what the drone sees, in real time. This creates an incredibly immersive and intuitive flying experience. It allows pilots to execute complex, high-speed maneuvers with pinpoint precision. They can weave through trees, dive under bridges, and skim just inches above the ground. It's this first-person perspective that makes them such a potent weapon. Now take that racing drone and make a few modifications. Instead of being optimized for crossing a finish line, it's adapted for the battlefield. Engineers and soldiers strap explosives to the frame. This could be anything from a simple grenade to a specialized anti-tank warhead like an RPG. The drone is no longer a racer, it becomes a guided missile with a human pilot. It's a kamikaze or suicide drone designed for a one-way trip. Its mission is to fly directly into a target and detonate, delivering its payload with surgical accuracy. This is the transformation from a hobbyist's toy to a military tool. The result is a weapon that is cheap, accessible, and surprisingly powerful. You can actually build a capable FPV kamikaze drone for a few $100s using off-the-shelf components. This has democratized aerial warfare in a way we've never seen before. You no longer need a massive defense budget or a state-of-the-art air force to project power from the sky. All you need is a soldering iron, some basic parts ordered online, and a pilot with steady hands. This low barrier to entry is what makes the FPV drone a disruptive force, changing conflict zones around the globe. Let's break down the tech. It all starts with the pilot. They're sitting somewhere safe, often miles away from the front line, wearing a pair of video goggles. In their hands is a radio controller, which looks a lot like a high-end video game controller with 2 joysticks and a bunch of switches. This controller is their connection to the drone. Every slight movement of their thumb on the joystick is translated into a command pitch forward, roll left, increase throttle. It's a direct one-to-one interface that allows for incredibly nuanced control over the drone's flight path. The drone itself is a symphony of simple, connected parts. At its heart is a flight controller, the drone's brain. This small circuit board takes the signals from the pilot's radio and tells the 4 motors what to do. The motors spin the propellers, generating lift. A small camera on the front captures the video, which is sent to a video transmitter, or VTX. The VTX converts the video into a radio signal and broadcasts it back to the pilot's goggles. All of this is powered by a high-discharge lithium polymer battery, which provides the juice needed for those high-speed maneuvers. The signal transmission is the invisible lifeline connecting the pilot and the drone. There are actually 2 separate radio links. The first is the control link, which sends the pilot's commands from the controller to the drone. The second, and arguably more important, is the video link, which sends the live feed from the drone's camera back to the pilot's goggles. The quality and range of these links are critical. A weak or interrupted signal means the pilot loses control, effectively flying blind. In a combat scenario, a lost signal means a failed mission, which is why operators often use powerful transmitters and specialized antennas. Finally, there's the payload. The explosive charge is wired to a simple detonator. This can be triggered in a few different ways. Often the impact itself is enough to set it off. The drone just has to hit the target with enough force. In other designs, the pilot might have a switch on their controller that they can flip at the last second to arm or detonate the warhead. The entire system is a masterclass in brutal simplicity. It's a flying bomb with a human eye, guided with the precision of a surgeon and the aggression of a hawk. On the modern battlefield, FPV drones are used in a variety of terrifyingly creative ways. The most visually striking tactic is the swarm attack. Instead of sending one drone, an operator or a team of operators will launch several at once. They converge on a single target or a group of targets from multiple directions. For defenders, it's an absolute nightmare. Trying to track and shoot down one fast-moving drone is hard enough. Trying to stop 5, 10, or even 20 at the same time is nearly impossible. 1 or 2 might get shot down, but others are almost guaranteed to get through, overwhelming defenses through sheer numbers. Another primary role for these drones is vehicle hunting. Armored vehicles like tanks and infantry fighting vehicles, once the kings of the battlefield, are now prime targets. FPV pilots have become specialists in exploiting their weaknesses. They don't just fly at the front armor, which is the thickest. Instead, they use the drone's agility to perform top attack maneuvers, diving down onto the thin roof armor, or they might aim for the tracks to immobilize the vehicle, or the engine bay at the rear to disable it. A successful hit can take a multi-million-dollar tank out of the fight, a stunning return on investment for a cheap disposable drone. The most common use, of course, is the kamikaze strike. This is the drone's primary function, to act as a precision-guided flying bomb. A pilot can guide the drone through a window, into a trench, or directly onto a moving vehicle with incredible accuracy. This turns every soldier, every vehicle, and every position into a potential target. The psychological effect of this is immense. Soldiers on the ground live with the constant threat of an attack that can come from any direction, at any time with very little warning. The high-pitched whine of a distant FPV drone has become one of the most feared sounds in modern warfare. This constant threat from above has a profound psychological impact on soldiers. It induces a state of perpetual anxiety. You can't relax. You can't feel safe even inside a fortified position or an armored vehicle. The enemy isn't just over the next hill, they could be directly overhead, watching your every move, waiting for the perfect moment to strike. This relentless pressure wears down morale, disrupts operations, and creates a level of stress that is difficult to comprehend. It changes the very nature of what it means to be a soldier on the front line, where the sky itself has become an enemy. Section 5. The Shield. How to stop a drone. You know, as quickly as FPV drones rose to prominence, a whole new industry has sprung up to counter them. The most common anti-drone tool is electronic warfare, specifically jamming. Jammers, well, they're devices that broadcast powerful radio signals on the same frequencies that drones use. This flood of noise, it overwhelms the drone's receivers. If the control link is jammed, the pilot loses control, and the drone will typically crash or fly away. And if the video link is jammed, the pilot's screen goes to static. They're flying blind, making it impossible to hit a target. Large-scale jammers can create protective bubbles over entire areas. But for a more direct approach, there are kinetic solutions. These are systems designed to physically knock the drone out of the sky. This includes everything from traditional anti-aircraft guns, which fire rapid bursts of bullets, to highly specialized systems. Some use programmable airburst ammunition that explodes near the drone, shredding it with shrapnel. There are also high-energy lasers and high-power microwave weapons being developed that can literally fry a drone's electronics from a distance. And at the simplest level, soldiers are often just using their rifles, trying to shoot down these fast-moving targets with regular bullets. Another popular method is using interceptor drones. Think of it as fighting fire with fire. These are specially designed drones, often larger and faster, whose sole purpose is to hunt and destroy other drones. Some are designed to ram the enemy drone mid-air, while others fire nets to entangle their propellers, causing them to lose control and crash. These interceptor drones can be automated, using onboard sensors and AI to detect, track, and engage targets without direct human intervention. This creates a fascinating dogfight scenario, played out by machines in the sky. Finally, there's the low-tech end of the spectrum. In many conflict zones, you'll see soldiers stretching large nets over trenches and important positions. These are crudely effective, acting like a giant catcher's mitt for incoming kamikaze drones. The drone hits the net and either gets tangled or detonates prematurely, away from its intended target. You'll even see makeshift cages, sometimes called cope cages, welded onto the tops of tanks and other vehicles. They're designed to detonate an incoming drone before it can make direct contact with the vehicle's thin top armor. It's a simple, but sometimes effective, last line of defense. Imagine the scene. A drone operator launches his FPV quadcopter. The motors spin up with a whine and it leaps into the air. On his goggles, the world is a smooth, fast-moving blur as he pushes the throttle forward, skimming low over the terrain to stay hidden. His target is a command post 2 miles away. He's flying fast, weaving through dead trees, his focus absolute. The drone is a tiny carbon fiber extension of his will, a remote-controlled weapon closing in on its prey. He feels the thrill of the hunt, the adrenaline pumping as the target grows closer in his video feed. But he's not the only one watching the sky. On the ground near the command post, a defender is monitoring a specialized radar system designed to detect small, low-flying objects. A blip appears on the screen. It's moving fast. An automated system identifies the radio frequency signature as a known FPV drone model. An alert flashes. Threat detected. The defender has seconds to act. He acquires the target with a jammer, a rifle-like device, and pulls the trigger. A powerful invisible beam of radio energy shoots towards the incoming drone. The offense has met the defense. For the drone pilot, the world suddenly dissolves into chaos. One moment he has a crystal-clear view of his approach. The next, his screen is a blizzard of multicolored static. The video link is gone. He's blind. He tries to pull up to change course, but the control link is jammed too. The drone no longer responds to his commands. Its flight controller, deprived of a signal, defaults to its fail-safe protocol. The motors cut out. The drone, now just a piece of plastic and carbon fiber with a live warhead, loses lift and tumbles silently out of the sky, crashing harmlessly into an empty field a few hundred yards from its target. This is the constant, invisible battle being fought every day. It's a high-stakes game of cat and mouse. Drone operators develop new tactics to avoid detection, like flying extremely low or using unpredictable flight paths. Anti-drone engineers, in response, develop more sensitive detectors and more powerful jammers. Some drones are now being programmed with basic autonomy, so if the signal is jammed, they can continue to fly towards the target's last known coordinates on their own. For every new offensive trick, a new defensive countermeasure is developed. It's a relentless cycle of innovation, driven by life-or-death necessity. For a long time, when people talked about military drones, they pictured something like the Predator or the Reaper. These are massive, airplane-sized machines. They are incredibly sophisticated, carrying high-tech cameras, sensors, and powerful missiles. They can fly for more than 24 hours at a time, loitering high above the battlefield, controlled by pilots in air-conditioned rooms halfway across the world. These drones are amazing pieces of technology, but they are also incredibly expensive. A single Reaper drone costs tens of millions of dollars. Losing one is a major financial and military blow. This high cost meant that only a few wealthy nations could afford to field a fleet of advanced drones. It was an exclusive club. They dominated the skies, giving them a huge advantage in conflicts against less technologically advanced adversaries. The barrier to entry for aerial warfare was immense. You needed a massive budget, extensive training programs for pilots and maintenance crews, and a complex logistical chain to operate these large, sophisticated aircraft. For most countries, and certainly for smaller non-state groups, this kind of air power was completely out of reach. Then came the FPV revolution. It completely flipped the script. The shift was from expensive, exquisite, and reusable systems to cheap, simple, and disposable ones. Instead of one $30 million drone, an army could now field 30,000 $1,000 drones. The technology is built on a global, open-source community of hobbyists. The parts are mass-produced for a commercial market, making them cheap and widely available. The knowledge of how to build, program, and fly them is shared freely on the internet. This is the democratization of air power. This shift has had a massive impact on the battlefield. Suddenly, even small, poorly funded groups can challenge large conventional armies in the sky. The playing field has been leveled in a dramatic way. A soldier in a trench with a modified racing drone can now pose a credible threat to a state-of-the-art battle tank. This change from large, expensive drones to small, cheap ones represents one of the biggest disruptions in military technology in decades. It's a move from quality to quantity, from complex systems to brutally effective simplicity. War just got a lot cheaper and a lot more accessible. The evolution of drone warfare is far from over. In fact, it's just getting started. The next major leap is the integration of artificial intelligence. Right now, most FPV drones are entirely dependent on a human pilot and a constant radio link. But we're already seeing the beginnings of AI-assisted flight. Drones are being equipped with onboard computer vision systems that can identify targets automatically. A pilot might fly the drone into a general area, and the AI would then take over for the terminal phase, locking onto a tank or a vehicle, and guiding the drone to impact, even if the video link is jammed. The step beyond that is the fully autonomous swarm. Imagine a scenario where a single operator doesn't fly one drone, but instead commands a whole squadron of them. They might simply draw a box on a map and say, "Find and destroy all enemy vehicles in this area." A group of 20 or 50 or 100 drones would then launch, working together collaboratively. They would communicate with each other, spread out to search the area, identify targets using their onboard AI, and coordinate their attacks, all without any direct input from the human operator. This would be a terrifyingly efficient and overwhelming force. This move towards autonomy creates a whole new set of challenges for anti-drone systems. Jamming becomes less effective if the drone doesn't need a constant signal to complete its mission. It can simply use its onboard AI to navigate and find its target. This forces defenders to rely more on kinetic solutions, things that physically destroy the drone, like lasers, guns, and interceptor drones. It also puts pressure on developers to create AI for the defense, systems that can automatically detect, track, and prioritize which drones in a swarm to shoot down first. We are heading towards a future where battles in the sky are fought not just by human-piloted machines, but by autonomous AI agents. The speed of combat will increase dramatically, happening faster than a human can react. Decisions to engage and destroy will be made in microseconds by algorithms. This raises profound ethical questions about the role of humans in warfare and the morality of killer robots. But the technological trend is clear. The future of drone warfare is intelligent, it is collaborative, and it is autonomous. The machines are learning to fight on their own. So, where does this all leave us? We're witnessing a classic technological arms race playing out in real time at incredible speed. It's a relentless cycle of offense and defense. For every new type of drone, a new countermeasure is invented. Drone builders then find a way to circumvent that countermeasure, which in turn leads to the development of an even more advanced defensive system. It's a cat-and-mouse game where the stakes are life and death, and the finish line keeps moving. There is no ultimate weapon and there is no perfect shield. This back and forth pushes innovation at a frantic pace. On one side, you have engineers trying to make drones stealthier, faster, and more resistant to jamming. They're experimenting with new frequencies, encrypted signals, and autonomous flight patterns. On the other side, you have teams developing more sensitive radars, smarter jammers that can adapt to new frequencies, and faster interceptor drones. It's a battle fought not just on the field, but in workshops and labs around the world. The moment one side gains an advantage, the other is already working on a way to neutralize it. This rapid evolution means that the battlefield is constantly changing. A tactic that was effective last week might be obsolete today. A defensive system that seemed impenetrable can be defeated by a simple software update or a new piece of hardware on the drone. This creates a volatile and unpredictable environment for soldiers. They have to constantly adapt to new threats and new technologies. The skills required to fight and survive are shifting from traditional combat prowess to a new kind of technological literacy. Understanding frequencies, signal strengths, and drone capabilities is becoming just as important as knowing how to fire a rifle. Ultimately, this isn't a game that can be won in the traditional sense. As long as cheap, powerful technology is accessible, the FPV drone and its descendants are here to stay. The offense will always be looking for a new way in, and the defense will always be looking for a new way to stop them. This endless race between the drone and the anti-drone is the new reality of modern conflict. It's a dynamic, ever-evolving duel that is reshaping warfare from the ground up, one high-speed, low-altitude flight at a time. The sky is no longer the limit, it's the new front line.